What's up, everybody? It's Coach Sharf. Welcome back to Algebra 2 note videos. And today is not going to be a note video, but it's an example video on our graphing characteristics of quadratic functions. So I'm going to start with the two examples I did in class. So if you watch the note videos after the first note video, we did x squared plus 6x plus 8 and found domain and range and all those things. So I'm going to do that one first. The second problem I'm going to do, we did the problem that's in vertex form, x minus 2 quantity squared minus 8. And that is on the in-class practice sheet, not your homework. Again, it's two separate sheets. The in-class practice sheet, that's problem number 3. So I'm already doing one of those for you right now. So if you got that sheet and weren't here when we did it in class, you can follow along and do that. If you were, you can make sure that you got everything right. While we're doing this again, I'm going to try to go, I'm not going to speed through it. I'm going to try not to speed through it. But I don't want this being a 45-minute video. So I'm going to go through talking about all of the different characteristics. I'm going to do those two problems. If I have time, I might try to throw one or two more on the end. But again, I'm trying not to make a 45-minute video or anything like that. But with that being said, let's go ahead and get started. So I'm going to jump straight to sharing Desmos with y'all. Again, it is desmos.com/calculator. You can kind of see it there in the address bar. Again, if you can't remember that, let me actually drag this down. If you go on to my Canvas page and you scroll down, you click on Desmos right there and it'll pop up. So I'm going to start with x squared plus 6x plus 8. And you can type it in on your keyboard if you're actually using your Chromebook or a computer at home. If you're on your phone, you're probably going to be using the Desmos keyboard. And you can also use that on your computer. So I'm going to pop that up. I want x squared plus 6x plus 8. So here's my x. A squared to give me squared plus 6x plus 8. All right, so, I'm down. My screen was down a little bit. I'll tell you what, let me actually refresh this. So I'm going to refresh it so it'll go back to what the screen looks like regularly. So we're right here. Okay, so again, I showed y'all how to do that. So I'm just going to type it in real quick. And again, change colors. The color doesn't matter. All right, so still kind of similar to what it looked like. You want to be able to see 4 things. Let me rephrase that. If you have 2 x-intercepts, so I don't think I did any problems where we only have 1 x-intercept. So if you have x-intercepts, you want to be able to see 4 things: the 2 x-intercepts, the that popped up, the vertex, and the y-intercept. So, a couple of these problems, I'm trying to let me pull this up to where I won't have any x-intercepts. So let me try 13. There we go. All right, so for this problem, we don't have any x-intercepts, but I still would want to pull it up to where I could see the vertex and the y-intercept. If we do have our x-intercepts, though, we want to be able to see everything. So where I had it originally, I could see the x-intercepts. I got the vertex. I couldn't see the y-intercept. So you can either scroll it up, or let me move my big old head. You can hit zoom out there to zoom out. So you can click and drag coordinate plane around. You can zoom out until you can see whatever you need to see. So now we're just going to run down the list. And again, this problem is going to be like, it's the first characteristics from the first set of notes. So it's like problems 1 and 2 on your 2 sheets. Okay. So I'm going to start by listing I'm actually going to do this annotate. So I don't have to switch back to active board. I'm going to do domain. So I'm starting with my domain. So throw this down at the bottom. So for my domain, again, how I kind of want y'all to think about this is again, it's looking at our X values. So which X values would my graph cover? This graph, there's no gaps in it. Again, it's not like it. Let me pull that up. Let me make this white. It's not like it, stops right there and jumps all the way down there and keeps going. Right. So I don't skip any X values here. And the assumption is, again, this looks like it's mostly going up, but it's going up and slightly left. But it's going to keep going left forever to negative infinity X. Same with this side. It's going to keep going up, but it's also going to keep going right. Even though it's only going right a little bit, it's going to keep going right. Oh, again, I'm flipped. So right a little bit, nothing's going to stop it from going right to positive infinity X. So my domain, when I write my domain and range, it's the set of X values the graph covers, but you almost want to think of it as what's the lowest X value my graph will go to. Well, this will keep going left forever to negative infinity X. This will keep going right forever to positive infinity X. And I said it in the notes, my domain for all my problems right now and in unit 3 is going to be negative infinity to positive infinity. It'll change later on in the year, but that's always going to be my domain for right now, but I want y'all to understand why. My range. So my range is my set of Y values that the graph covers. So again, I'm going to put my comma. So now I'm trying to think outside. How far up and how far down the graph goes, basically. So if one end's going up to positive infinity Y, if one end's going down to negative infinity Y, and there's no gaps, like we said previously, our whole range is covered. We know with the parabola, that's not the case because either both ends are going up or both ends are going down. In this case, both ends are going up to positive infinity Y. So positive infinity Y is going to be the highest Y value that my range gets to. My graph's going to keep going up to positive infinity Y. Now going down, the lowest Y value is right here. So it's at my vertex. And again, you need to be able to look at this and say, okay, this is 0, this is 5. So this must be counting by ones, -1, -2, -3, -4, -5. My lowest Y value is -1. Again, the fortunate thing about Desmos is though, I can actually click on the vertex and see that the Y coordinate is -1. So my lowest Y coordinate, lowest Y value is -1. And if I have a number here, that's when I put the bracket. Okay. If this were to happen to be flipped, okay. Trying to think what I got to make negative to make this work. There. All right, if this were to be flipped, the whole thing flipped. So my vertex actually moved up here to -3, 1, but now my range would be flipped because find somewhere I can click and drag this. All right, because now both ends are going down to negative infinity. So the bottom of my range would be negative infinity, and the top would be +1. So if the graph is flipped upside down, the bottom of my range is going to be negative infinity. The top is going to be the highest Y value. All right. So let's fix this back to what we had. Plus. Let me just leave that like that. All right. So here's my domain and range. My x-intercepts and y-intercepts, again, y'all should know how to find those. I've done those for a long time. So my x-intercepts are going to be where it crosses the x-axis, my y-intercept where it crosses the y-axis. again, in a test situation, you gotta be able to look at this without clicking on it. So if I'm looking at my x-intercepts, I got -1, -2. So -2, 0. -3, -4. -4, 0. And again, I'll click on it in a second so you can see it. Y-intercept, where it crosses the y-axis, right here. So I got 5, 6, 7, 8. So 0, 8. And again, the thing you got to realize is I got to pay attention to my grid. Let me zoom in. We were zoomed in. See, now this is even easier. It's actually on 8. If we kept zooming in, well, it would still be on 8, but I might zoom out. Trying to zoom out where it might be counting by 2s. There we go. So now it's counting by 2. So if I happen to be out this far, 0 to 10. So now these aren't 1s, these are 2. So you'd have to recognize 2, 4, 6, 8. All right. So you gotta be able to recognize them. But again, you know, if you're just doing the sheet, you can click and say, all right, there's my x-intercepts, there's my y-intercept. All right, my vertex is at -3, -1. Again, vertex, the highest point or the lowest point. So -3, -1. And again, I want y'all to put if it's the maximum or the minimum point. In this case, it's the minimum point, the lowest point of my graph. All right. The next thing on the list is the axis of symmetry. So I told y'all that you got to be able to kind of, well, I mentioned it in some class. I don't know if I mentioned it in every single class, but the axis of symmetry is almost got to be something you can visualize because, you know, I don't think I'm doing this on Zoom when I would draw. Otherwise, I was using the active board. I don't think y'all had the ability to draw on it, but you know, I can do my line going straight up and straight down. So this is a line that goes through the vertex that, again, makes this symmetrical. It looks, you know, the same on the left side as it does on the right side. So if I'm looking at that line now, this is where I got to say, okay, so let me look at some different points on this line. This is -3, 4. This is -3, -9, or positive, excuse me, positive 9.5. This is -3, 13.14. Spitball there. But all these have an x value of -3. So for my axis of symmetry, I'm just gonna put axis for shorthand. It is the line. Again, this represents a line, not a solution to anything. The line x equals not +3. I've been doing that all week. -3. All my points on this line have the x coordinate of -3. All right. So again, the little shortcut in lieu of you drawing the line, whatever my x coordinate is here, that's what my axis of symmetry is going to be. So if this was 5, I would write x equals 5. If this was 12, x equals 12. It's -71, x equals -71. All right, so a few more on this one. Let's clear everything. So I got my increasing and decreasing intervals and my end behavior. I'm going to put inc and dec for short for interval of increase, interval of decrease. So for my intervals, you know, some of y'all at the beginning of the week, particularly the odd classes, so third period and fifth period, we're talking about, I kind of want you to read this from going from left to right. So read the coordinate plane going from left to right. And then as soon as you hit the furthest portion of the graph, we start to trace it as it goes right. So as it's going right, it's going down. So I think it's almost a little easier. Instead of doing it like that, say find the farthest left portion of the graph, the farthest left point of the graph that's still in view, which is up here. okay, at the very top. If, if I had a parabola that was looking like this, it would be down there. So the farthest left portion, then I'm just going to start to draw it. So as I'm drawing this, is this going up or down? It's going down, it's decreasing. Okay. So my decreasing interval, again, this other assumption that we got to make before I forget, this portion of my graph is going to keep going up forever. It's not going to go up and turn back down here at any point. So no matter how high I go, and let me drag it so I can show y'all. No matter how high I go, or how far left I go, again, I'm going up and I'm still going to the left slightly. Again, I'm going more straight down here, it appears, but this even more so shows that I'm decreasing. Okay. And even more so shows that I'm decreasing. So my decreasing portion of the graph, again, if we start on the left, we assume we're starting at negative infinity x and going to the x coordinate of my vertex, which is -3. The increasing portion, so now my graph starts to go up, and again, it's going to go up forever and right forever. So it's going to keep going up from -3x. This is -3x right here. Again, the vertex is -3, -1. From -3x to positive infinity x. So my intervals should cover my entire domain from negative infinity to positive infinity. I go negative infinity to -3, -3 to positive infinity. Again, there's no gaps. Okay. It's not like I'm drawing my graph here and I stop and I just skip here and keep going. Okay. All right. So here's my intervals and increase or decrease. My end behavior. I want to draw, I need different color. So my end behavior. So what are the two ends of my graph doing? Again, I showed y'all with the pipe cleaners. Y'all can tell me the 4 in about 15 seconds. Probably less than that. Both ends are going up. Both ends are going down. Left end is going down, right end is going up. Left end is going up, right end is going down. You gotta be able to explain it to me in mathematical terms. So what I'm going to say is, as x approaches negative infinity, so as x continues to go left, my x values, again, this left end is going up, but it's going left. It's going to keep going left forever to negative infinity x. So as this is going left to negative infinity x, is it going up to positive infinity y or down to negative infinity y? As it's going left. So as it's going left, it's continuing to go left and up. Okay, so as x approaches negative infinity, y is approaching positive infinity because my y values are going up. Other side, now this right side, it's going up, but it's going to the right. So it continues to go right to positive infinity x. So as x goes right, x approaches positive infinity, y is still going up. So y is again approaching positive infinity. So when y'all are writing this now and in unit 3, all this is always going to be the same. As x approaches negative infinity, y approaches. As x approaches positive infinity, y approaches. This is the only thing that changes. These could both be positive infinity. My parabola is pointing down. They'd both be negative infinity. If the left end was down, right end was going up. Left end would be approaching negative infinity, right end would be approaching positive infinity. Oh, come on, draw. There. Positive infinity. And then if this was flipped, my left end is going up to positive infinity, and my right end would be going down to negative infinity. Again, these ones we'll see in unit 3. So for right now, these are both going to either be positive or both be negative. And again, everything up until that these infinity signs is going to be the same. All right, so there is all my characteristics when I'm looking at an equation in standard form. All right, so I'm going to clear everything out. I'm going to delete all that. Click and delete on my keyboard. So now I'm actually going to do number 3 on the in-class practice. So if y'all are looking at it, again, I'm going to type it in using the Desmos keyboard, parentheses x minus 2, parentheses a squared gives me my squared, minus 8. All right. So again, this is pretty close. We dragged it up a little bit. I can see my x-intercepts. I see my y-intercept. I need to drag it down just a little bit to see my vertex. So everything I want is in view, so we're good. So again, we're going to run through this one a little more quickly now. Again, trying to save time on the video. So my domain, I'm still looking at the same thing. Still have a parabola that's pointing up. This end is still going to continue to go left to negative infinity x. This end is going to go right to positive infinity x. So my domain is still going to be negative infinity to positive infinity. My range, yeah, I'm going to have a range. Both ends are going up to positive infinity y. So that's going to be the top of my range. The bottom of my range is my lowest y coordinate. So again, you got to look at it real close, as I'm doing right now. And I can see that it's going to be at negative 8. Again, you got to be able to do that on the quiz, because you can't just click on that point. You're not going to be using Desmos for the test. So you can't just click on that point and see it's 2, negative 8. So my y coordinate is negative 8. All right, my x-intercepts. So again, with your x-intercepts now, this is where it's going to get a little, not tricky, but it's not always going to be at even numbers. I mean, your y, I think for pretty much all the problems we do now, your y-intercept will be, it's not necessarily going to always be at an even number either. But again, if you're just looking at these, they look like they're at -1 and 5. Okay, they do look like that. Again, if I just gave this to you on a quiz and said, tell me what the x-intercepts are, if y'all told me -1, 0 and positive 5, 0, I'd be okay with it. In a test situation, though, again, they're going to be specific. They're not going to. So let me put a few answer choices up here. So your first one would be -2, 0, 6, 0. Again, we're close to -1 and 5, not -2 and 6. -0.828, 0, 4.828, 0. 2, -8, 0, -4. So these 3 answer choices, we know it's not going to be A. C is my vertex and actually my y-intercept, which we'll get to in a second. So here's B. D, again, D, this is why I'm telling you they're not going to do. They're not going to tell you D is -1, 0, 5, 0. Pardon me. I'm sorry. I apologize for that. They're not going to tell me -1, 0, 5, 0. Right. So D is not going to be this answer choice where, again, it looks like it's a -1 and 5 where y'all would pick that. But the answer is actually B, because if you look at it, again, let me actually click so it's not highlighted and the points aren't showing up. So it should be even more obvious. This doesn't get all the way to 5. This doesn't get all the way to -1. So this wouldn't be your answer choice for D. You know, I don't know what they might have there, but in a test situation, again, if you're given these 3 and something else for D, you know it's supposed to be close to -1 and positive 5. That's close to -1. That's close to positive 5. So that would be your answer in a multiple choice test situation. Again, for this worksheet, however, though, I have the ability to click on while I'm in Desmos. So I can just say negative 0.8280 and 4.828. My y-intercept. My y-intercept is going to be, again, right here, I should look like it's 0, -4. If you click on it, it will actually be, it crosses at -4. Again, if you click on it, it's actually 0, -4. All right, the vertex, again, is, you can click on it to -8. We already saw it earlier. Again, let me actually erase this. So I'm erasing my mark. That dot is still there. So to -8, the axis of symmetry. Again, the x value of whatever my vertex is. So x, the line, x equals 2. So there's those. All right, clear this out. Intervals of increase, decrease, and end date. So my interval of decrease, again, if I'm starting up here, obviously I'm decreasing, okay? So I'm decreasing from -infinity x to positive 2x. And I would be increasing from, yeah, I'm doing the different colors just so y'all can see it, to positive infinity. My end behavior is actually going to be the same as it was on the first problem, because both my ends are going up. So as my left end approaches -infinity, so as x goes left to -infinity, y is going up to positive infinity. So as this goes left, it goes up. As this end goes right to positive infinity y, or excuse me, positive infinity x, excuse me. So as x goes right to positive infinity, my end is still going up to positive infinity y. I do have to, oops. I do have duty, but I gotta finish this video first. So there's that. All right, and the other 4 things that we're now looking for are going to be those graphing characteristics by looking at the equation. So my transformations. So my horizontal transformation, or my horizontal translation, excuse me. Again, mostly looking at how the vertex moves. Since we have the graph, we do have the benefit of showing if we assume the vertex started at 0, 0 at the origin, it went right and it went down. We can also get it by looking at the equation though. So this -2, if I got a number inside the parentheses next to x, that is my horizontal translation, horizontal shift, and it goes the opposite sign of what you think it's going to do. So if we're talking horizontally, we would think -2 would be 2 to the left, but it's actually a shift 2 units to the right. My vertical shift, again, I'm shorthanding with vert. So my vertical shift is going to go in the same direction as you would think. So -8, you would think would be shift 8 units down, which it is. So I went right 2, down 8, and there's my vertex. A reflection. So again, we talked about the different reflections, but really, you know, I'm not going to ask you if it's over the x-axis, over the y-axis, or at the vertex. Really, I'm just going to ask if it's flipped upside down. Yes, we have a reflection. If it's not flipped upside down, no, we don't have a reflection. So there's no reflection. And then a stretch or a shrink. Again, represented by the Any number, any coefficient in front of X, there's not one, so I would say there is none. Okay. So there's that. All right, last thing I want to show, again, just a couple differences y'all might see. So first thing would be, I'm going to add a couple things to this. Throwing a -2 out here might be enough. Okay. So throwing a -2 out there might be enough to show everything I want to. All right. So first thing, we see this graph. So there's no X intercepts. It doesn't cross the X axis. That means I have two imaginary roots. If I was trying to solve this equation, if I made it into standard form, which would be -2x squared plus 8x. I think it would just be plus 8x because I'd have -8 and a +8 that would cancel out. No, that can't be right because I should be able to get at least one solution to that. I think I messed with math. Maybe it's -16. Yeah, it's -16. So -2x squared plus 8x minus 16. I don't happen to have any x-intercepts. So in this case, for x-intercepts, I would put, well, I'll go ahead and put it. I should have talked about range first. X-intercepts, I would put none. Okay, my range, again, I showed this on the first one. If it's flipped upside down now, both ends are going down to -infinity. So that's my lowest y value, my highest y value. It's now the top of my range, which again, in this case would be -8. Y-intercept still the same. Vertex is still the same. Axis of symmetry, even flipped upside down, would still be the same. My intervals of increase or decrease. So again, I'm still got one interval of increase, one interval of decrease. Now, my interval of increase just happens to be first because as I'm going right, now I'm going up. So my interval of increase would be -infinity to 2. My interval of decrease would be +2 to +infinity x. That's a terrible infinity. What else? The transformation. So still a shift, 2 to the right, 8 down. My vertex is still there. So for reflection, I know I'm keeping it green, but I'm trying to finish the video. I would put yes because it flipped upside down. For my stretch or shrink, I would put, so I have one, again, if it's greater than 1, it's a stretch. If it's less than 1, shrink. So I would put stretch. If it was less than 1, I would put shrink by a factor of whatever the number is, not the negative. Negative's only telling me reflection. So even if I have a negative, I'm ignoring the negative. So it's stretch by a factor of 2. Shrink by a factor of 1/4 if there was a 1/4 out there. Okay. All right, so clear all that out. Get rid of that. I think I could stop sharing. So that should be everything you need to do these worksheets. All right. Send me a message and remind if y'all need any help. Good luck on finishing these worksheets. Make sure y'all study for the test next week, and I'll see y'all in class.